Ladies and gentlemen, presenting How to Serve AI with Data, please welcome Joseph Sirosh, Corporate Vice President, Data Platform.
On either side of me is a timeline of the Earth. It's 4.5 billion years old. As you follow that timeline, I want to highlight Earth's 4th billionth birthday. It's the Cambrian period, also a time called the Cambrian explosion. That's when oxygen levels on the planet rose and evolution unlocked the ability to see. And that's when life decided it was time to party. There was an incredible explosion of life at the Cambrian period in a very short time span of 80 million years. Precambrian, single-celled organisms, post-Cambrian, rich, intelligent animal life. This was an evolutionary singularity. And now, fast forward to today. Today, we are at the verge of a Cambrian-like explosion in technology driven by artificial intelligence. This is an AI singularity in the making. Before now, software was simple and stupid. With the advent of AI, software applications are exploding in sophistication and intelligence and variety. And you and I will be there to see it. There are three fundamental drivers of this revolution. The cloud allows you to bring massive compute and collect data from all types of devices and applications from all over the globe and integrate them together. Powerful data platforms then allow analysis of all of that data. And finally, innovations in AI algorithms, they allow you to understand the patterns in the data and be predictive with it. In many ways, cloud is the ocean in which AI is being born. Data is its oxygen, and intelligence is the vision of the Cambrian-like explosion of AI. Our mission here in Microsoft is build for developers the tools that empower you to participate in this explosion. So today, we have powerful data platforms hosted in the cloud and also in hybrid modes operating on-premises and in the cloud, relational databases, global distributed databases like Azure Cosmos DB, which you saw today in Scott's keynote today, and data lakes for analyzing petabytes of data and business intelligence. And we offer a very rich variety of tools for artificial intelligence. Microsoft R Server, which now integrates Python as well, Cognitive Toolkit for deep learning, Azure Machine Learning and Cognitive Services, which you heard about in Harry's keynote. And then massive compute. The cloud today provides incredible infrastructure for AI, such as Azure Batch Learning, and hardware, cutting-edge hardware like the latest GPUs and field programmable gate arrays, FPGAs, that accelerate AI computation to entirely new levels. So let's take some more examples. Azure Cognitive Services. Azure Cognitive Services is a rich collection of 31 APIs. It allows you to see, allows software to see, vision. It allows software to process language, understand speech, search intelligently, and extract knowledge from vast amounts of data and use that in your apps. And you can compose these APIs available on the cloud very easily to infuse AI into existing software applications and build these applications in a far more agile fashion than ever before. The best way for me to show this is with a demo. Coram Thompson is an engineer in my team. Within the span of a few days, he was able to compose cognitive APIs with other services in the cloud and build an extremely powerful application which really serves to show how you can infuse AI into an application and have a reliable, hosted SaaS application extremely fast. Let me invite Coram to show you that demo. Coram?
All right, hey everybody. I'm Coram, and this is the Library of Congress. It's the largest physical and digital library in the entire world and costs almost $500 million in order to preserve works that have national historic significance. Now, I've never created anything worthy of this great library, but I do have things that have personal significance that I would want to preserve with my family. And so that's why I created the Library of Coram. Let that one sink in for a little bit. Now, I don't have the resources of the federal government, but I was able to create this in just a few days using the magic of Azure Search combined with cognitive capabilities. But in order to populate this library, I needed to dig deep into my personal archives. So located behind the ball pit in my daughter's room is a secret door that leads to all my greatest treasures. In one of these bins, next to that plaster cast of my face, don't ask, is a stack of letters. These letters represent 2 years of my life that I wrote home to my family, detailing my adventures as a service missionary for my church. Now, these are the closest things that I have to a journal and something I want to preserve and share with my children. So I just wish there was a machine that you could drop these into and push a button and have it automatically create a library for me. Well, it turns out with just a few lines of code written in Azure, you can create one. And so the way it works is I drop this into my office copy room printer, I type in my email address, and then I hit the green button. And all the documents are scanned, sent to the cloud, processed and analyzed. And by the time I'm able to walk back to my desk, this is what I have. This is the Library of Coram. It's a single-page HTML application that I generated with just a few clicks using the AZ Search.js library on GitHub. You can see that it contains all of my scanned documents. Some are typed, but most are handwritten. You can also see that it's been faceted with using natural language processing. We're able to extract things like people and places. Now, from this alone, you can already learn a couple things about me. One, I was serving in Texas, and that I'm from Seattle. And one of these names, Elder Hogan, is someone that I had a lot of great adventures with. And so if I click on his name, it can pull up just those parts of the documents in which I talk about him. So let me dig into one of those right here. So you can see here that we have the original document as well as the words that have been extracted from it. Now, as I scan through this letter, I'm reminded about when we would get bored, we would go into the desert and we would catch lizards that we would bring back to a habitat we built in our apartment. Let me see if I can find that real quick here. So I'm going to search for lizard habitat. And there it is, equipped with the ant farm that was connected in order to automatically feed the lizard when we were gone. And you know what? I'm also reminded about this time that we provided service for the Carrasco family. We did this by shearing their sheep during the hot summer. So I want to find that. Shearing sheep. And there you have it. Something magical actually just happened. In addition to being able to find the story in which I talk about that, it's also able to find a photograph. Now, the reason why this is because I scanned those photographs the same way I scanned any of the other documents. And if I select on this document, you can see that our Vision API is able to extract words from this as well. In this case, it says, a man petting a sheep, outdoor barbecue. Yeah. In all fairness, I don't know that the sheep knew my intentions either, so. What's great about cognitive search is that even when the AI is less than perfect, it's still useful to find things. Now, is there anyone out there that wants to see a live demo? Yeah. All right. OK. So I have with me another thing I discovered in my attic. It's a collection of letters that I wrote when I was about 10 years old. And one of these letters is about a buffalo hunt. Why don't you get a good look at this, memorize this page, because using the magic of cognitive search, I'm going to make this document appear in that computer over there. OK, ready? So in order to do this, I'm just going to use my cell phone. And I'm just going to use the regular camera app, nothing special going on here, and take a picture. All right, so if everything goes according to the plan, in about 30 seconds, this guy should show up automatically into the Library of Quorum. Now, you might be wondering, well, how exactly does this work? How do these things go from these physical items automatically into the Library of Quorum? Well, let me show you. The key to this is putting your data in the cloud. Whenever I take a picture on my phone, the photos are uploaded to OneDrive, and things that are scanned are sent to my Office 365 mailbox. Now, I can quickly configure Microsoft Flow in order to take these images and put them into Azure Blobs. As Azure Blobs, they can be automatically indexed by Azure Search. And to add intelligence to search, I wrote an Azure function that calls our cognitive services like the Vision API in order to enrich the index. Now, that might sound complicated, but let me just show you how simple that actually is. This is the Azure function that is doing this processing. You can see that for each document, we extract each of the pages as images. Then we send them here to the Vision API. And then I use a local library in order to extract the entities, such as people and places. And at the end, I just insert them into the index. It really is that simple. Now, let's check to see if this is in my catalog here. All right. Moment of truth. We're going to search for buffalo. Ah, yes. And there it is. All right. Now, your your treasures may not exist behind a secret door inside of your house. Most of the world's information is locked up in digital attics that are hidden away and constantly growing, not producing value. They often are the digital equivalent to this. This is a real customer that sent us this image of all the things that they have to collect. Even though digital files don't take up physical space, they can be just as daunting as this room. Imagine trying to make sense of all of this in order to find something that you need. Azure Search, infused with cognitive capabilities, can be your key to harnessing AI to unlock these digital attics and discover new business value. Thank you very much.
Quorum, I didn't know you were such a great artist.
Well, maybe when I was 10.
That's right. Yeah, I got it. So Quorum showed you how easy it is to infuse AI into every software. You can make software start to understand, interpret meaning of text, voice, and images. You can have software that reasons with data and learn from its history. You can have software that interacts with you in natural ways through cognitive bots. Very powerful. So as we build these kinds of powerful platforms, there is one very important principle behind all of this. Remember, today's AI is all about learning from data. It is not like AI 50 years ago, where a lot of the focus was on logic and reasoning and languages like Lisp. Today's AI is all about inferring and learning from data. And so it's very important, then, to bring the computation of AI to where the data lives. In today's world, when people build AI applications, they often pull data from lots of data sources. They integrate that, they join it, they compute variables, they compute models, and then they have to keep that model in a secure harness, highly available, reliable, and so on. And the overhead associated with this is incredible, which is why you see very few software applications that are truly AI-based. It's very hard to do so. But you can simplify this. If you move all of that logic of data analysis, data joining, and variable computation, and all of that into the data platform tier, then the application tier can be dramatically simpler, and all the complexity can be managed by the database. And that's the right thing to do, because the databases of today already support incredible scale, a high availability, concurrency, it secures your data, and when you minimize data movement, when you don't have to slosh around large amounts of data, you can have extremely low latency and high throughput. All of that becomes possible. And so now, how would you move AI into the data platform? You need a kernel. Microsoft R Server 9.1, that is the data science kernel for us. It has R and Python packages for scalable, efficient machine learning. It's got pre-trained cognitive models. It even supports GPU-based deep learning. And it allows enterprise-grade support and operationalization. It truly is the best of Microsoft's machine learning capabilities and open source blended together in a package that can run on Windows and Linux, can run on Hadoop and Spark and SQL Server. It's truly cross-platform. So how do we infuse that kernel of AI into a relational database management system, RDBMS? We started with SQL Server. SQL Server 2017 now allows AI stored procedures with Microsoft R Server, and of course, Python as well. And when you use the magic of in-memory analytics and aggregates in SQL Server, together with the stored procedures that are executing inside the server itself, you can get incredible throughput and scale. 1 million plus predictions per second throughput for example, a fraud detection task that we benchmarked on. In addition, it has graph support. It allows you to analyze complex relationships, represent and analyze complex graphs, all in SQL Server. When you combine that magic with the machine learning capabilities that are in there, you can build extremely powerful applications. This is why SQL Server 2017 is the first commercial database that can claim to have AI built in. It's an efficient, agile, secure harness for deploying AI. The best way to show this is through a demo and code. So now let me invite Romit Girdhar to show us a powerful demo of deep learning inside SQL Server. Romit?
Thank you, Joseph. Hello, everyone. So thank you, Joseph, for having me. Today, I want to show you some amazing intelligent features that we've added within SQL Server 2017. Now, I've built an application that actually enables GPU computation on top of your data using Python, Cognitive Toolkit, on SQL Server 2017. So let's get right into it. As you can see here on my screen, I have a sample fashion finder application. And in that application, as you can see, I've got a catalog of clothing images. And based on the image that I select from this list here, the website's going to recommend similar items to me from the catalog. Now, the similarity here is defined by a deep neural network that we've trained that's trained to look at different features, such as the neckline of a shirt, the sleeve length, and the pattern. So let's get into it and see how it actually works. I'm going to go ahead and pick this shirt right here. And as you can see, it's actually shown me some really good and similar samples based on the shirt that I just picked. And that's how easy it is. So if I'm a shopper that's not really sure if I like the color of the shirt or the pattern, this is a really good shopping experience for me. But we all know that's not exactly how we do shopping always, right? We also like to look at our celebrities, see what they wear, and then go out and buy something similar and sport that as well. Well, thanks to deep learning, we now have a capability within this website that allows me to upload an image onto the server, where my SQL Server can quickly look through the image. The deep neural network will recognize the clothes worn by the person in the image and then recommend similar clothes from the catalog. But before I show you a demo of that, I want to first quickly walk you through how we built this application. So let's look at the architecture at hand. All right, so here's the architecture. And as you can see, everything apart from the website is contained within SQL Server 2017. Now, the question you may ask is, all I see is stored procedures, so how is it that you've added intelligence? And so this is actually one of the great features we've added in SQL 2017, which is Python-based stored procedures. What that allows me to do is bring in deep neural net models and also create custom machine learning models right in my SQL Server. So now you can make your application smarter with your data sitting in your SQL Server. No need to go anywhere else. Ladies and gentlemen, we're now bringing compute right to where your data is. All right, so what did we do in this architecture? We took a DNN model, which was pre-trained with millions of images, and we took the catalog of images, clothing images that you just saw, and we refined the DNN to learn on these images. Once it learned on those images, we then recognized it to learn the different features, such as the neckline, the sleeve length, and so on and so forth. And then it was able to recognize these features. It could also recommend different clothes to us. And so at that point, it actually truly became smarter. So let's go ahead and take a peek under the hood and see how we actually built that application. So as you can see, this is my familiar SSMS, SQL Server Management Studio. And I've pulled up a stored procedure. It's a common-looking stored procedure, except for one piece. I have the ability to add a script parameter. The script parameter here is a Python script that I've added. And if I actually just expand this, you can see it's a Python script that I've created right here. In the Python script, I'm actually calling the model from my SQL. Now, you'll ask me, where is this model actually being stored? Do I have to go to the cloud for this model? No, no, no. It's actually stored right in my SQL Server. And there you have it. I can actually zoom in right here. And as you can see, it's actually stored as a binary within my SQL Server table. And so now I can actually use Python to call this model and make my application smarter. All right, so let's see how it works in the application layer. So we've built a Python application on top of the Flask web framework, for those of you familiar with that. And here I have a function that's basically calling a query where it's executing a stored procedure. And in the stored procedure, what it's also doing is it's also passing an image URL. This is the URL of the image that I'm going to be uploading. It goes back to this, it executes the stored procedure, gets me my response, and tells me which items are similar to the item it just looked at. All right, so now that we've taken a look at all of this good stuff, let's also take a look at the demo of how we actually built this. So as a thank you for bringing me on stage here today, I wanted to buy Joseph a nice little sweater as a gift. Now, I wasn't sure what his style is, so I looked through some photos of his and tried to come up with a nice picture. And I came up with this picture. And just to tease me, he wore the same sweater today. But let's see if our website can recommend some similar clothing items based on this picture. So let's go ahead and move over to our website, upload our image. And now what it's going to go is it's going to go back to SQL. It's going to execute my stored procedure, recognize the clothes Joseph's wearing in that image, and it's going to come back and recommend some similar items to me and tell me which ones I can buy. And there you have it, folks. Lo and behold, I think we might have the next fashion fad that's going to sweep the nation. Joseph, I really hope you like this sweater. I'm looking forward to seeing you in this. Thank you again for having me. Thank you.
Thank you, Ramit. Did you click the buy button for me?
Of course, it'll be on your desk on Tuesday.
OK, thank you. So Azure SQL Database is our fully managed global read-scale service on the cloud to make development with databases as easy as possible for developers. Now, today, Azure SQL Database has global read scale with change your application. It has automatic failover policies. It's got data replication to any region. And it allows you to build extremely reliable, fully managed applications on the cloud. And today, we announced Azure SQL Database Managed Instance. This allows full SQL Server compatibility for databases in the cloud. It allows you to migrate existing SQL data applications into the cloud. And once you have those applications in the cloud, remember, you can infuse AI into these applications extremely easily by having the AI run inside the database itself. Now, the managed instance is very powerful because it gives you 100% of the capabilities that you're used to in SQL Server for many editions going back. SQL Agent, cross-DB queries, R, CLR, Service Broker, all of those things. Very powerful. So now I'd like to introduce a customer of SQL Server, Stack Overflow. Let me play a video.
Stack Overflow is the world community of software developers.
It's used by over 40 million people every month, looking for answers to their questions, looking up documentation, and finding new jobs.
Developers love Stack Overflow to the tune of about 6 billion hits a month. Stack Overflow itself only runs on 2 SQL servers, one for the read-write workload and one for the read workload. But we're talking about 10 and 5% CPU. One can more than easily handle the load. We're just preemptively scaling out, so we have a ton of headroom.
People are surprised when they hear that Stack Overflow can run on a single SQL Server instance because they just don't realize how much scaling you can get out of SQL.
We trust it because it's highly available, it's highly reliable. It's one of the most rock-solid pieces of infrastructure we have.
We always say we want to use the best tool for the job, and we'll always choose the best tool, whatever it is, at any time. What amazes me is just how little hardware that we need, and we have literally saved millions and millions of dollars. Stack Overflow Enterprise is a version of Stack Overflow for large corporations that want to allow their own internal developers to ask questions about their internal code privately within the firewall, rather than asking those questions on the public internet.
With SQL Server with SP1, we can run the same code entirely on both platforms, and customers that need enterprise scale buy enterprise, and customers that don't need that can buy standard and run just fine. From a programming point of view, it's easier for us and easier for them.
One of the greatest things about the transformation that Microsoft has undergone is the willingness to work on every possible platform. That really makes their offerings, including SQL for Linux, including all the offerings from the consumer all the way up to the professional developer and the data center, much, much more compelling. My favorite thing is when a developer comes up to me and tells me how much Stack Overflow helped them. That's really awesome. They're usually thanking me as if I had answered their questions, but it's really the population of Stack Overflow.
And today, I have the pleasure of hosting Alex Miller, General Manager of Enterprise Stack Overflow. Alex?
Thanks so much for having me, Joseph.
So, Alex, what's the vision of Stack Overflow?
Well, thanks. And I guess first question is, has anyone here ever heard of or used Stack Overflow before? All right, a couple people. Great. So you probably know Stack Overflow as that place you go to copy and paste code when you run into a programming problem, right?
That's how I learned R, by the way.
OK, there we go. Well, really, beyond just Q&A, we're here to kind of help developers learn, share their knowledge, and level up their skills in their career. And at the same time, we want to help companies better understand, hire, and enable those developers. So like I said, we've done that with Q&A on kind of the public stackoverflow.com website for a long time. But we also do that now through Stack Overflow Enterprise, which helps large companies and teams collaborate kind of privately and securely on those things they can't talk about publicly.
And what excites you about SQL Server and Azure SQL Database?
Sure. Well, the great thing about Azure and the combination with SQL is that we've been using SQL since the beginning. It's incredibly performant. You saw how many hits we get to the website each month. I mean, I looked this morning, there are 100,000 concurrent sessions on Stack Overflow running off of one server. And with all the tools in Azure, we've been able to seamlessly offer that same application architecture for our clients in the cloud. And so they're getting the exact same code base and experience from stackoverflow.com just for them in their own kind of completely isolated environment.
Right. And how about Azure database migration? Are you excited about that?
Absolutely. So we're big believers that we can actually offer a much better experience for our customers if we're running it for them in the cloud versus the on-prem version, because we offer both right now. So helping them migrate very easily from those existing on-prem installations and get it into the cloud seamlessly, again, without having to change the application architecture, and in very little time is great for them and really great for us, too.
Great. So what are you thinking about for the future?
Well, everyone already is kind of using Stack Overflow today, I think, for getting those questions and answers, right? Finding information faster. And that really benefits the individual developers at a company. What we're really playing with now is how we can use some of the AI and cognitive tools in Azure to actually give companies better insight to where their teams are getting stuck. So that, hey, we can get more training on this area. We can build out more documentation. Or we can do extra looks on this because, hey, the last version of this application wasn't quite where it needed to be. So just letting companies get better insights and better better proactive actions so that their teams are more efficient from the beginning.
Thank you very much, Alex.
Thanks so much.
Yeah. I'm hoping for an AI-infused Stack Overflow to overcome my natural stupidity. So let's talk about the Azure Database Migration Service. It's new, just announced. We are streamlining database migration from SQL Server or even from competing databases. You can migrate from any of these, migrate data into a fully managed PaaS service on the cloud, or even SQL Server VMs. And remember, moving the data to a cloud-hosted app can be your first step to this journey to AI that you're about to undertake. Now, again, as before, let me show a demo. let me invite Akash to show us a demo of migrating databases to the cloud and building an app. Akash?
Thank you, Joseph. Hello, developers. My name is Akash. Hi. Today, I'll show you how easy it is to migrate your on-premise SQL Server databases to Azure SQL Database and using the new, just announced Azure Database Migration Service. So here's what we will do. I have an enterprise Stack Overflow application that is powered by databases on an on-premise SQL Server instance. We will migrate these databases to an Azure SQL Database managed instance using the new Azure Database Migration Service. Then we will point the web application to the new instance and show you that the application works seamlessly without any code change. So let's start. Okay, not able to present it. Give me just one moment over here. I'm not able to show my screen. Okay, there you go. So this is the Enterprise Stack Overflow application that I was talking about. If you scroll to the bottom of this page, you can see that it is powered by Microsoft SQL Server 2016, an on-premise instance. Let me go over to Management Studio. So this is the on-premise SQL Server instance that has the two Stack Overflow databases and which is powering that particular application right now. I have pre-provisioned an Azure SQL Database managed instance, and we will migrate these two databases from the on-premise SQL Server instance to the Azure SQL Database managed instance live in a blink of an eye. So let's start. To do the migration, I have pre-provisioned an instance of Azure Database Migration Service, and I'm calling it Get to SQL. I can click on the new migration project to create a new migration and do the migration using the beautiful Azure Portal UI experience. But you know what? I'll be honest over here. I'm a developer at heart, and like most developers, I love working in command line. So let me introduce you to my friend, PowerShell. Since the migration service is a native Azure service, it supports PowerShell commandlets. So I will use this particular commandlet to do the migration. I will point it to the Get to SQL service instance, give a project name, provide the source server name and credentials, target server name and credentials, and ask it to migrate all the databases. So let's go ahead and run this. Let me quickly enter the source server credentials and the target server credentials, and it should just submit the request. There you go. It's already queued the request to the migration service, and the migration service has picked up and started processing. So what's happening behind the scene? Once, and by the way, this is a live migration. This is a real service that is deployed to Azure, and that is right now processing the request. So behind the scene, it migrates all the databases in parallel. And for each database, it will take a complete backup, upload it to Azure Blob Storage, and then restore it from there into the managed instance. And as we speak, you can see both the databases completed total time just in 28 seconds. Now, let's go to Management Studio. And let me just refresh. And there you go, both the databases in Azure SQL Database managed instance. OK, so now the next part. We still need to go and change the connection string of our application. So for that, I've created a CMD file, and I'll just run it. It will change the connection string and also go ahead and reset the app pool. So let's go back to the Stack Overflow application, refresh, and just since recycle the app pool, just bear with me over here. It will take a couple of seconds, and the site should load. Maybe a few seconds or a couple of seconds. OK, and there you go. Here it is. If I go to the bottom of the page, it's now connected to Azure SQL Database managed instance. So now the migration is complete. The last step, let me do this. Let's go to an existing post, a question. Someone is asking for pointers of how to migrate databases to Azure. In fact, it's just me. I just created this question. So let me answer this. Use Azure Database Migration Service. Let me just give my name. My email address, and post my answer. This is right now pointing to Azure Database Managed Instance, and there you go. The application just worked without any code change. So, to summarize, we did a live migration. Can I just point to that one? Which is this one?
5.
Okay, to summarize, we did a live migration of the enterprise Stack Overflow databases from an on-premise SQL Server instance to Azure SQL Database Managed Instance, which is the new Azure migration service. And once the data was in Azure, we showed you how the application just works seamlessly without any code change. Thank you.
Thank you very much, Akash. And all this took just a few minutes.
Of course, yes.
And once the data is in Azure SQL DB, well, then you can have federated query from Azure Data Lake and analyze all of that data, correct?
In fact, you'll be amazed to see the cognitive capabilities in Azure.
Yeah.
And I'm sure they'll see it soon.
Thank you very much. Very powerful. So this, by the way, is part of the power. Once you move that data into a platform like Azure SQL Database, well, then that service is something that is accessible to analytical services across Azure, such as Azure Data Lake, which is a capability to directly query those databases and pull data and then analyze it and even attach cognitive intelligence into all of that data. And so you are able to blend all of these together in powerful applications. So now let me talk about the Azure Relational Database Platform itself. Now, Azure SQL DB is built on a very powerful PaaS harness. It's intelligent, it's flexible, it's trusted. Intelligent in that it has advisors to optimize the performance. It allows you to tune the system. It allows you to monitor your databases. It's flexible in that it allows on-demand scaling. It allows resource governance. It's trusted in that it takes care of high availability. You don't have to worry explicitly about keeping replicas. For example, the premium databases have up to 3 replicas to ensure that your application never goes down. It has disaster recovery. It has got backup and restore and security and audit and isolation. And all of this is built on Azure Compute and Storage, which runs in 38 regions today globally. And so now take that harness, and let's now drop in other databases that developers love, such as MySQL and PostgreSQL. And suddenly the power that's opened up to you in a fully managed service is immense. And that's exactly what we have done. Today we announced MySQL, Azure Database for MySQL, and Azure Database for PostgreSQL in preview. And these services are fully open source compatible. You can work with your familiar tools from any platform, Windows or Mac or Linux, and migrate applications that run on Postgres or MySQL to this managed instance, to the fully managed service in the cloud, using very, very simple code. And the best way, again, to show this to you is with a demo. Now, let me invite Saloni Sonpal, who's a program manager in my team, to show you how. Saloni?
Hi, folks. I'm Saloni, and I'm going to demo the new managed service for PostgreSQL in Azure. What I'm going to do is take an existing app, which is written in Python on GeoDjango framework. It uses a PostgreSQL database and the Postgres extension for spatial data types. 3. Thank you. As you can see, now what I'm going to do is take a backup to migrate it to Azure. This generates a dump file. I upload it to Azure File Storage, then go ahead and create an Azure database for PostgreSQL, restore this dump file into this new database, and point my app to Azure Database for PostgreSQL. You wouldn't have to learn any other new tools, frameworks, and your app continues to work. Now, say the load on your server increases. You would just be able to scale on the fly by using a simple Azure CLI command. Let me demo this through an existing app. here's my app. It's a Python app. And as you can see, it points to the local instance of PostgreSQL. I'm going to run this app. And let's see it live in action. You can see it's a map of the United States and also a heat map of all the people that are logging into the Build conference. As you can see, the number of users are increasing as the time passes by. Now, what I'm going to do is try to migrate this app, or rather database, to Azure. For that, I'm going to go to the Azure portal and create the Azure database for PostgreSQL. The familiar plus new experience that you're aware of. Here's the service. And you can fill out the form with the required information. A couple of things to note here are we are available in multiple regions across the world. We support multiple versions of PostgreSQL and MySQL. And you should be able to scale and configure your performance based on the requirements of your app. I'm just going to go with the lowest version of compute units and the included storage. In interest of time, I've gone ahead and pre-created this server. It's called PG Build Demo. It's a 9.6 version of PostgreSQL located in West Europe. I'm going to connect to it with the Cloud Shell that was announced earlier today. What I've gone ahead and done is also taken a backup, upload this dump file to Azure File Storage. I have also gone and mapped this Azure File Storage to Cloud Shell using Cloud Drive. I've also done is created a DemoDB database and also created a Postgres extension on it. As soon as this Cloud Shell loads, what we could see is the Cloud Drive and the dump file in it. What I'm going to do is go ahead and restore into my database. While this goes ahead, what I'm going to do is update the connection string of my app to point to this Azure database for PostgreSQL. Let's see if the restore finished. It's restoring. But as you can see, I'm doing this with the familiar tools that you're aware of, PG Restore. When I created the database, I used the familiar tools, pSQL. The restore seems to have finished. So what I'm going to do is take a peek into my database to see if the rows really got in. And there it is. Now, I'm going to run the app. And voila, it continues to work against this new database in Azure. The users are increasing, and as you can see, the compute units are also getting utilized. Now, the heat map should also go up as time passes by. Say the load on the server increased drastically. Now, I want to scale this database on the fly. I'm going to go to Bash Shell and just update the compute units to 100 to handle the extra load. And voila, the compute units also show it increased to 100. And as easy as that, I was able to scale up my server on the fly. So first time ever, the first-party managed services for PostgreSQL and MySQL in Azure. So what are you waiting for? Get started today.
Saloni,
Thanks,
that's
Joseph.
amazing. And you demonstrated all this from a Mac.
Yes, absolutely. Isn't that impressive?
Right. On a Mac with open source, Azure is truly a cloud for open source development now. So now let's talk about a new type of database. Today we literally live on a planet of the apps. Our customers for cloud apps, are from all over the globe. Data flows in from IoT devices and mobile apps and websites, and the sources are all over. And like in the case of mobile apps, customers are sometimes roaming. And they expect low latency. And while customers are global, we have sort of, as developers, gotten used to thinking about databases as local. Single servers, well, maybe replicas to have high availability. We never think about global distributed databases. And that's what Azure Cosmos DB announced today is. One of the first globally distributed multi-model database service. It's geo-distributed. It's multi-model in that it supports many models such as NoSQL, a graph API, documents, all of those models and more to come in the future. And you can scale to any need, and it offers comprehensive SLAs on access and read and write latencies. So let's see a little bit more. It gives you global distribution as a turnkey. It supports even SQL queries. It has a MongoDB API. It has key value and column family, document, and graph models. And by the way, the document databases, as a document database, the JSON documents are automatically indexed for you. So you can do very powerful queries on all of that. And there's global distribution, elastic scale-out, separately of compute and storage, guaranteed low latency, less than 10 millisecond read latency, and less than 15 millisecond write latency at the 4 nines. Very, very powerful for applications that are truly distributed and global in nature. So behind the power of Cosmos DB are fundamental innovations. Some of you may know of Dr. Leslie Lamport, the Turing Award winner, who invented also the Paxos protocol. His innovations and a lot of innovations from Microsoft Research are behind the scenes enabling this power that you see in Cosmos DB. Let's hear it in Leslie Lamport's words.
Cosmos DB is a database system in which the data can be replicated and copies distributed throughout the world. This permits an application to be configured so every user is near a copy of the data without the application programmer having to worry about how many copies there are or where they're located. The Cosmos DB team credits TLA Plus with helping them provide great SLAs to our customers. The work of other researchers at Microsoft Research and elsewhere was crucial to developing the 5 different consistency models that Cosmos DB allows developers to choose from. I believe that today, commercially available databases offer only 2 choices: perfect consistency, sometimes called strong consistency, and eventual consistency. Cosmos DB provides 3 additional intermediate choices. I expect that developers will use this flexibility to obtain the trade-off between consistency and performance that they find best for their applications.
Great. And Cosmos DB now has a Spark connector that allows you to analyze all of the rich data in Cosmos DB from a Spark layer. And with me, I have the pleasure of inviting Andy, who is from Blackboard Transact and uses Cosmos DB. Andy?
Joseph,
thanks for joining us.
Thanks very much.
Andy, what's the vision for Blackboard?
So Blackboard provides software, services, and hardware to the education community around the world, ultimately to drive positive outcomes for the students and the learners around the world. We have a product vision today that's organized around unifying our products into a platform architecture. And today we're executing that platform architecture on the Azure cloud.
Great. Andy, how is Azure Cosmos DB used in your application?
So today, our product architecture focuses on a cloud-centric platform as a service model. And today we're building out a rich catalog of REST APIs that we expose to our customers and our partners to be able to integrate with us. Those REST APIs are architected as microservices And those microservices are giving us tremendous flexibility to be able to have different tech stacks, independent deployability and scalability. And we're building those microservices out on top of the Azure Data Platform. We've chosen Cosmos DB for our database as our go-to database because it's demonstrated to us the ability to perform exceptionally well at scale, at cloud scale for our customers.
What kind of query throughput do you see?
So today we're seeing write operations in the thousands of transactions per second. We're able to achieve the goals that we've got for our financial systems today that we're building on top of Cosmos DB. A big part of that is the fact that we have a predictable consistency model, as well as very low latency, which is exceptionally important for our financial transactions from a user experience perspective when they're on campus trying to buy something.
That's great. And what do you see as the future of Blackboard Transact?
Well, this is an exciting time for us. I mean, the platform architecture is opening up a lot of opportunities for us. The value proposition of the platform and Cosmos DB is unmistakable for us. And so we're going to continue to build out on top of that as a platform, as well as to embrace some of the analytical capabilities that are available to us. Ultimately, in order to derive tremendous business value out of the mountains of customer data that we manage.
Great. Thank you very much, Andy.
Thank you very much.
So when you have vast volumes of data such as this coming into the cloud, how do you analyze it all? That's where you need an intelligent lake. In the cloud, we have Azure Data Lake, which allows you to operate on petabyte scale data, and in fact, infuse AI into all of that data, making it an intelligent lake. It's a very powerful petabyte scale analytical system. Now, it can host deep neural networks, and today it has a capability for 6 cognitive functions: face API, image tagging, emotion analysis, OCR, and so on. And now, with the power of Azure's AI infrastructure, you can train large deep neural networks, take those, infuse that into the intelligent lake, and build very powerful analytics with it. To introduce this to you and describe this with a demo, let me invite Brett Tanzer, who is a Partner Group Program Manager in Azure. Brett?
Great. Thanks, Joseph. How's everybody doing today? Getting near the end? Great. So as Joseph said, my name's Brett Tanzer, and I'm the Group Program Manager for the Azure Big Compute team. We run all that beefy infrastructure of highly performant GPUs and CPUs connected in the cloud to make all of this AI possible. And so, as you know, in the world of AI, big compute and big data often go hand in hand. But when you want to do training and deployment of custom AI, you really need 3 things. You need the ability to work with your massive data sets using the tools that you know and love on any open framework. You need the ability to go do all of that training using the interconnected fabric of GPUs in the cloud so that you can get your training and retraining done quickly. And then you need to be able to infuse all of that intelligence back into your applications and data services. So today, I'm going to be Brett, and I work for Contoso Media. We're a large stock image house, and we've got millions of images stored in our data lake, but cataloging each one of those is a very complicated task. We have to look and figure out the subject matter of the image, how it gets attributed. We have to make sure that's continuously updated as more subjects get added, and so a little custom AI could really go a long way to taking a very manual process and making it incredibly automated. So today, I'm going to show you a demo that starts in Azure Data Lake with our collection of millions of images. It uses a Cognitive Toolkit 2.0 model, and we're going to optimize that to go recognize landmarks, because those are hot in the market. I'm going to do it right from within Visual Studio so that I get access to the familiar tools that I know and love. Then I'm going to show you how easy it is to take that and burst it to a new service that we're introducing today for AI, called the Azure Batch AI Training Service. That's designed to give you the ability to take advantage of that fabric of GPUs with little fuss and make it possible for you to do it very efficiently in the cloud. Then I'll show you how we can integrate that back into our user applications and data services to deliver a little user magic. Are you ready? All right. Let's see. Let me log back in. And here we go. So let me switch. That'll take about a second. So here I am. I'm in my Azure Data Lake. I've got about 12 million images, and this is the problem. Can you imagine if I had to click on each one of these images here, look at it, catalog it, and update the metadata? It's just incredibly unscalable at this point. So what I'm going to do is I'm going to start here in Visual Studio. As you've seen a few times today, what I have here is I've got a Python script that I'm using to train an existing cognitive toolkit recognition model based on my collection of landmarks. See all the standard CNTK methods? Because I'm doing it right here in Visual Studio, I get all the benefits of IntelliSense, and I can make sure that my job is functional and ready to run before I send it to the cloud and start paying for those large-scale training costs. So that's good. My script is ready, everything is done, I've checked it out, and now I want to send it to the cloud. Now, the Azure Batch AI Training Service, it exposes a set of AI-optimized APIs, so I could call those right here from within my script, or I can use this UI we've built today to demonstrate it. So I'm going to go here, and I'm going to click Submit Job. This is just a very simple form, and what it allows me to do is load the pre-created job definition file. I could switch some of the hyperparameters on my model if I wanted to do multiple experiments in parallel instead of doing one large-scale run, but I'm not going to do that today. And then I'll go ahead and I'll hit Submit. Now, when I hit Submit, I'll switch over to my Azure portal, and as you see, my 40 nodes are starting to light up. That script has literally been sent to the cloud, farmed out across these 40 nodes, and now each one of them is working on stage data, and it's doing training of this massive model. I did very little to take advantage of these GPUs, and guess what? As Microsoft continues to bring out the latest generation of GPU technology, these solutions will continue to work. So now, this job is going to take about 5 minutes, but after 5 or 7 minutes, after I'm done, what I'm going to have is a DNN that I'd like to be able to use inside my applications. So let's go back to Visual Studio. So now, the Azure ML Studio is going to enable a couple of things. The first thing that it will enable is it'll enable me to take that DNN and publish it to an endpoint or a REST API so that I can call it from any web-enabled application. The second thing it's going to enable me to do is take that and publish it into an Azure Data Lake or SQL Server, as you saw earlier, so I can go use that to enrich my data application. So here, as you've seen a couple of times today, I have basic USQL. Millions of SQL developers already know how to add AI to their existing apps using data lakes and USQL. It's very easy. I've got a basic process. It's going to identify the landmark in each of the photos of the data lake. It's going to go do the select through the row set, start to iterate above them, and then update it in my CSV. Now, doing this also could take about 20 or 30 minutes. So what I'm going to do is I'm going to replay a job that we started earlier. And this job actually took about 10 minutes. It was on a subset of the data set. And so then when I play it back, what you see is that the whole process of preparing the data, queuing the data, iterating through each of the items in the row set, and then updating the metadata and the index with the information about which records have landmarks. All of this is done pretty easily using only a few lines of script, as I showed you earlier. So now, so far you've seen me start from my Azure Data Lake. You've seen me build a Python script to train an existing CNTK model and optimize it for my set of enterprise data. You've seen how the Azure Batch Training Service makes it possible for me to use that fabric of GPUs in the cloud to easily do training at scale. And then you've seen me take it back and publish it into a data lake. Now let's see how an end user might experience this. So here, I've got an app we've built. It's really used by the sales folks inside my organization, and it's called the Where in the World app. What it's designed to do is take any image, recognize the landmark in it, and then plot it on the map. As you can imagine, this would be valuable if you were a salesperson who needed to go sell people all the images for things that were happening in Paris if they wanted landmarks. So that's the purpose of this app. So let's go ahead and get started. You'll see that I've got a few landmarks here. I can go select the Eiffel Tower, and then it'll call the DNN that we just built, and it'll correctly recognize the Eiffel Tower and place it there. I can go ahead and choose the Taj Mahal. That's another image. I'll select it. It'll correctly call the endpoint. It'll recognize the Taj Mahal. But what if I wanted to identify them all? Now, I can click the Identify Them All button, and all of that intelligence that we infused into the data lake earlier, you're starting to see the power now. Because as I start to iterate through the collection, it's selecting only those images that have been identified as landmarks and mapping them on my device here. So I can go zoom in, and if I want to see the landmarks that are cropping up around Europe, I have the Eiffel Tower, I have the Piazza San Marco in Venice, I've got the Leaning Tower of Pisa, and they're all coming online. It's really just that easy. So with that, so it really is just that easy. With that, you've seen how in a few minutes I can train a hyperscale model, use it in the cloud, and publish it into an application for end user consumption. Thank you very much.
Thank you very much, Brett.
Thanks.
That's a landmark issue.
See you.
So the power of the services in the cloud is the agility it brings to developers. So let's look at what we saw today. In the first demo, Khorram showed us how to build AI applications by easily composing cognitive services, Azure Search, and other functions. Then we saw how to embed AI in databases and make your apps intelligent. Next, we saw how to migrate database applications to the cloud with incredible ease and host all of that app in the cloud and the data so you can infuse AI into it. And then you saw instant migration of a Postgres application from on-premises into the cloud into a fully managed service on the cloud that gets all the benefits of that fully managed harness. And then we saw how to build globally distributed apps with Cosmos DB, a first-of-a-kind data service in the cloud. And Brett then showed us how to harness the power of all of that AI infrastructure to do big AI, and then embed that in a powerful analytics platform like Azure Data Lake to do big cognition. This is incredible power, folks, for all of you. So let me draw a parallel. 530 million years ago, when evolution unlocked vision, an incredible explosion of intelligent life happened, the Cambrian explosion. Today, we are at the forefront of unlocking AI for all developers. And before us is an explosion of software sophistication unlike what we have ever seen before. That is our future. And this time, all of us developers are here to see it. I invite all of you to build that future with us. Thank you.